Hi and welcome everybody for the SUSE QE Tools Workshop of 2021 November 19. Today topic will be mainly led by Jan about his idea to use Terraform to openQA settings. Then welcome, over to you. You're already sharing your screen. Go ahead.
Yeah, thanks. Thanks for the introduction, Ollie. Hi, welcome everyone. Glad that you made it today in the morning or whatever time of day it is in your part of the world. So I'm Dan. I'm kind of a sort of QA person, but I've been playing around with openQA a bit over the past years since I joined SUSE. And recently I've played a bit with Terraform, found it quite useful, and I thought maybe we could apply it. So let's dive right into what is this all about. So what would I like to cover? So this is just a really rough so this is just a really short presentation. Give you a bit of an introduction, mainly what is Terraform, since I don't expect everyone to have heard about this. So if you've never heard about Terraform, don't worry. I'll try to explain it. I'll probably fail. So feel free to interrupt me. If anyone could please look out for raised hands if there's any questions, since I really just have one screen. I
Yep, we
won't see
will.
any raised hands in Jitsi. Okay, great. So yeah, I'll first cover what is Terraform and what should this Terraform provider for openQA do. And then I guess the main part of this will be more or less of a discussion. Is this useful? Would you like this? Would you like to have it? How can we implement this? So let's dive right into this. So what on earth is this Terraform thingy besides something that we'd like to do to Mars or maybe Venus? So Terraform, it's also a tool created by HashiCorp, who you might know from other tools like Vagrant, Nomad, stuff like that. And this is an infrastructure as code tool. So this is it's a tool that's mostly used. You define yourself an infrastructure for a public cloud or a private cloud. Think of that like for your AWS, OpenStack, Google, GCP, Azure, whatever you like. You can do all kinds of stuff like defining, hey, I have these servers over there. I'd like to now spin up 5 instances of an AVS micro. It should have this image in there. I'd like to put in those data in there, this firewall, etc., etc. And Terraform is used to manage to a configuration language for this. And it also provides you the tools to apply these settings. So, but the cool thing about Terraform is it's actually in a more broadly speaking, it's a tool that you use to apply a desired state to a system. And it also tracks the states that it applies, and it can be used to apply the desired state and undo stuff that you did previously. So think of it if you use this to spin up your 5 AWS instances, then if you find out, oops, these small instances, they are not cutting it. So let's convert them to large instances. It would be now pretty terrible if you'd have to manually undo all the stuff that you did. So Terraform takes care of that. If you change some property and it decides, yeah, I'll have to destroy these things, then it will clean up after you, which is pretty nifty, and we can use that for other things. Yeah, and this I already covered. So Terraform is mostly used in the context of public and private cloud provisioning. So for AWS or also for OpenStack. I hope this broadly covers Terraform, how it works. Terraform works roughly like this. You create a so-called state file or a Terraform file where you define your whole infrastructure. So this is really the basic example of a Terraform file that I just stole from their documentation. So this is the really basic one where you initially define a provider. This is essentially your connector to in this case a public cloud, so AWS, where you just say, yeah, I want to use the AWS provider, need this version, and then you define the connection. And here in this example, they just set one simple resource. So this is, as you can already see, the configuration language is this is using the so-called HCL configuration language. I think Terraform also supports JSON, but most of the stuff that I have seen is using this HCL stuff. But it's relatively straightforward, and in practice, you really don't have to interact with that a lot. Cool thing about these files is also Terraform so the Terraform developers, they've created also a language server for this. So if you're using a text editor or an IDE that supports the language server protocol, you get all the niceties of the language server protocol, and it's also aware of most of the Terraform settings, which is pretty cool if you want to work with that. So how do you actually use this? So mostly you really just need 4 commands. If you want to start out using it, you run terraform init. This will set up your working environment. Then if you have written your Terraform config files, you type in terraform plan. That will give you, then Terraform will tell you what it needs to do to reach your desired state. If you want to apply the state, you do terraform apply. And if you've decided, yeah, let's get rid of that stuff, terraform destroy. And I must confess that's literally all I've used of Terraform. I think I might have used the graph feature, and yeah, that's been about it. So let's take a look at a few features that it has. I already covered this mostly. So if you've Terraform tracks the state that it created. So if you've created instances and then you re-execute Terraform Terraform apply, then if you've now reduced the number of instances that you want to do, it will undo that. So really, this is something that I find very handy, because if you've essentially you don't need to include some cleanup code in your provisioning setup. Terraform also has a plugin system, so all of these, as you saw in this file that I shared, that I've shown you, these connectors to public cloud instances, that's really just these are so-called providers, and they all use an SDK or a plugin system. So this is all very flexible. And can be used to connect to literally everything. I think I've seen even a provider that connects to some pizza delivery API. Whether that's now really a good fit for Terraform is debatable, but I think I've seen that.
So, question on that: do you mean literally pizza, or like is it some cloud provider that actually has the ordering backend, or how does that work?
No, I think it was actually for a pizza delivery. So you could write your pizza order into a Terraform file, execute Terraform apply, and it would order a pizza for you. I'm not sure if it wasn't a joke. It could have been a joke. I mean, it's most certainly a joke, but it might have been a joke that didn't work.
I
But I
think it's a
wouldn't be
good
surprised.
workflow and a good example of how you can integrate services. It's not uncommon to see something like
Yeah, I think it's actually a rather bad fit for Terraform, since
Okay.
ordering a pizza is more of a... So Terraform is something that you would use to manage a persistent state. And ordering a pizza is not necessarily a persistent
Yeah,
state, because you
it's
order
a
the
single
pizza, the
action.
pizza arrives. Yeah, the
The
pizza
state that you
arrives.
want to achieve is I have a pizza, right?
Yeah, but then pizza and the pizza won't stay. So
Yeah.
anyway, and what also is relatively nice about Terraform, since it's built with the idea of support of having of spinning up public cloud infrastructure, it has built-in support for secrets. So you can define variables as sensitive, and you can include them from the environment, from configuration files, and Terraform will do its best to hide all these secrets that it sees that you give it. Okay, so let's maybe take a quick look and do a little bit of a demo, since I think that taking a look is always the best. So what I've got here, I hope that's readable and big enough. So this is an example that I've created a while back, and this is really just a relatively simple Terraform recipe to spin up four virtual machines in our engineering cloud, which is running on OpenStack, and this deploys K3s. So it deploys a K3s server and 3 clients. And so let's maybe just go through this. So here's the main block, which tells Terraform that it should use the OpenStack provider at a certain version, yada yada. Then we have 2 types of instances: the server instance, where you can tell it how it should be called, the image, the SSH key, and so on. And then the agent. Here you can see it creates 3 agents. As a side note, this user data thing, these are maybe let's cover that later. So we have the 2 machines. So we have the 1 server, 3 agents. Now the agents should be spun up after the server, since the server needs to get up first. So we tell Terraform that the agents depend on the server and also on the floating IP association of the server, which is just this OpenStack thingy, so that the server gets a floating IP that's reachable from the outside. And then, as a side note, is that the actual provisioning is done by Cloud-init, and sorry, I should have now the language server is running. It's not finding it. Anyway, and so I've got a few template files in here that just render some provisioning scripts. So I don't think I want to really go into too much detail here, since this is maybe getting a little bit beside the point. But anyway, so I already have these files set up here. So now I would essentially run Terraform plan. If you're wondering, this environment variable that I'm setting before that, that's the OpenStack secret. So now in the output of Terraform plan, you'll see it tells me what it all will have to do. And since I haven't deployed that, it tells me 6 to add, 0 to change, 0 to destroy. So let's just do a apply. It will again tell me what will be done. I'll type yes, that this should be performed. And now Terraform will connect to OpenStack and it will start performing its magic. And if we go to the engineering cloud, let's go a bit of a zoom level, you'll already see that the server has been, it has already started creating the server. Now it's currently creating the agents. If we load this thing, then we should already see the agents
what are the
created.
agents also being individual machines, right? Yeah.
Yes, these are also three. These are individual VMs.
Okay, so you end up with 4.
Exactly. Yeah, and it's now already done. Yeah, and we can now take a look at these. So they should be now booting up and performing cloud init. No, they're waiting for a network connection, but yeah. So this they would now spin up and do their cloud init magic. And
it says 6 resources added, so that had been 4 machines and 2 something else.
One of them is the floating IP.
Right.
And then let me take a look. What's the last one?
So maybe 2 network resources. Just to get an idea, resources means VMs and something else could be like a generic.
One of them is it can be a network, it can be an SSH key,
right.
It can be a floating IP. In this case, it's in this case the 6th one is the cloud init file that's been rendered.
Right. So resource is really something that exists afterwards outside of the context of Terraform. I can see
exactly.
in the OpenStack interface that there is a cloud init resource which needs to be linked to VM somehow, right?
Yeah. So yeah, it's now doing its thing. So resources really can be more or less anything. There's even the concept of so-called null resources that you can use to make Terraform do stuff. So one of the what you sometimes end up doing is, and what I've done in the past a few times is to run Ansible or some other provisioning thingy on your VMs afterwards, is that you define a null resource, which is then used to run your actual provisioner, because Terraform has no inherent concept of Ansible itself. But then you define a null resource, and there you can let it do anything that you like. And then this provisioning thing is also a resource.
Right. There was a hand raised by IOB. Hannes, go ahead.
Yeah, one question. This except the computer agents, don't you need also Swift and other components to make Swift, for example, for storage, to make the openQA works in full?
I didn't.
What's the
I
minimum
didn't get that.
requirements? Okay, what's the minimum requirements to run the openQA in OpenStack?
That's not the point of this. Really, I'm just showing you currently Terraform. This has nothing to do with openQA yet.
Oh, okay, sorry.
Yeah, I was probably unclear about that, but this is really just a demonstration of what you can do with Terraform. I'm not trying to run openQA in OpenStack.
Okay,
It could be possible.
Yeah, because I will expect also other components of OpenQA to be able to run the full openQA. Yeah, thank you.
Okay, so maybe let's just take another look at Terraform plan, what it currently does. So it will now take a look how the current infrastructure looks like. So it will refresh all these states. And if we wait a teeny tiny bit, it will tell us what in our infrastructure has changed. So what's the difference between the existing state and the that we have defined in our configuration file and the state that's currently on OpenStack. So you can see there's just a few tag differences in the definition, and it now tells us what the IP of the server is. So, but that's roughly about it. And since we don't need this thing anymore, I'm just going to quickly destroy it. So here, Terraform will once again refresh it.
So this destroy, will that get rid of everything you created so far?
Yes, exactly. The floating IP, it will get rid of all the nodes. If I would have uploaded images, it would have destroyed them. Our SSH keys, essentially everything that's in there will now be gone.
Phoenix.
If we take a look now.
Can I add something here? So, Chris, in principle, how this works is that Terraform maintains a state file locally. It's the df state file, and because it keeps its state within that file, Terraform can make those changes. It knows exactly which resources it has applied. It can make diffs between a new plan and the already acquired resources, and it can act among the state file. This is why operations like modifications and destroy work so efficiently.
Yeah, exactly.
Nice.
Thanks.
Thank you.
Yeah. So now we got rid of this thing. And if I once again refresh the engineering cloud, you can see that the server is now gone. And we are back at the clean slate. Okay. Maybe any more questions at this point that are general about Terraform itself?
None right now, so go ahead.
Okay, so I said let's make a Terraform provider for openQA. Now you might be wondering, okay, so do you want to deploy this thing to some public cloud? And that's not what I was envisioning. So what I thought is, well, Terraform is pretty good at applying a certain state to a system and manage state changes and clean up after us. So how about we use Terraform to manage essentially the database of openQA? So we have the tests. We keep already our tests in Git, but then there's all the other stuff, and that's test suites, machines, products, templates, all of this stuff that's not in Git, that lives in the openQA database, and this is the very important stuff of openQA, and at least from my experience, that's also the part where many people really struggle keeping it in some way updated. So I've seen so many hacky scripts where we try to set test suits, where we try to set job groups, etc. pp. I've seen CI jobs created by various teams in SUSE, outside of SUSE, who just try to not use the database at all, so that they can really run all their tests from Git itself, and then don't use a lot of the openQA feature, because they don't want to rely on anything being in the database. So I would say let's use Terraform for this. Let's say we'll add a provider that will allow us to manage test suits, that will allow us to manage machines via Terraform. Thereby, we really don't have to modify anything inside openQA. I mean, in a perfect world, we'd read all of the settings that are currently in the database from Git. That would be perfect. But unfortunately, the world is not perfect. We have this stuff in the database, but we have an API of openQA, and we can make it talk to Terraform. And then we can manage our state via Terraform, and we can essentially have all of our tests in Git. And the nice thing is, we don't even have to do this centrally. Every team, so we could have an openQA instance, and we could have 5 different teams, and each team could manage its own machines, its own test suits, its own job groups, and they could all have Terraform, apply these settings. If they mess something up, Terraform would clean up everything that it created, and people wouldn't step on each other's toes. Yeah, as I already said, with this, we could really get rid of various scripts that essentially try to do this. But at least with the scripts that I've written, my scripts, they never clean up after themselves, because it's just keeping track of the state. That's just work. And already getting these settings applied is already hard enough. So then automatically cleaning up, that's really a whole ton of work. So that's why at least my scripts unfortunately don't do that, and that's why I only test them on my local machine and periodically have to just kill the whole openQA instance because it's littered with crap. And sorry for using such hard words, but yeah, my openQA instance is not pretty. And this have the advantage that we could make tests really, really portable. Because at the moment, you start developing tests locally, and if you modify test suits, yeah, have fun sending this to openqa.opensuse.org or even some other instance. So if all these settings would be managed by would be read in from Git and could be applied, then it would make this stuff truly portable. I mean, not absolutely universally portable, because once you go to the general hardware backend, you have essentially said bye-bye to any kind of portability. But in a general sense, this stuff could be really portable. So how could this, for instance, look like? So this is just really a rough draft. You would say, yeah, I openQA provider, I define my server, my API key that I read from a variables file, my secret, and I could use that to connect to, in this case, openqa.opensuse.org. You could even, I mean, you can of course also read in the URL from the environment, or the provider could also, of course, use the config file. So this is just just an example. This is how maybe test suits could look like. So you say we have a resource that's called openQA test suite. We give the thing a name, we give the thing a description, and we apply various settings which would map to the variables that we define in each that we define in the test suites in openQA. Could do the same thing for machines. I mean, it looks quite literally the same. Monkey, sorry, it looks quite the same like a test suite, because it's more or less the same thing. Yeah. And with that, maybe a rough estimation. What do we need to actually do to get this thing? So Terraform is written in Go.
Yeah, very short
And
note from Anton. Anton, go ahead.
Yeah.
Generally, it might work and might bring us benefits, but the one thing which I want to clarify is that as Felix correctly mentioned, Terraform has a state, and I don't see how it will fly if everyone will run their own Terraform instances. Then we would really step on each other's feet. So the only thing how I see it will work, if we will have a single Terraform executor which have a single state, and people will apply their changes via doing pull requests to some central repo. Then when pull request is merged, there is some, I don't know, job which running constantly and keep this state of the Terraform repo with configuration up to date with what we have in Terraform. So we cannot allow to like any random person run Terraform apply on OSD. It will not work. It will create a mess and destroy a lot of resources.
Yes, but you could so what you can also do is so yes, generally you are correct. If we would deploy this and use it really, then this stuff would have to be centrally managed. But Terraform can also import existing state. I haven't played with this exactly, but but provided you don't you don't keep creating and destroying stuff all over the place, you could also import the existing state into your current Terraform state.
But even if you will import this state, imagine about the concurrency. So two persons at the same time import the state which is now, and then they do conflicting changes. And then, it's...
then stuff breaks, of course.
Is the same as if two people manually do stuff over SSH at the same time, right? I mean, and
exactly.
we still have some locking on the level of openQA, so that two people cannot edit same test suite at the same time. Okay, there was another hand raised from Pavel. Pavel, go ahead.
Yes. Well, I was consulting this with a friend recently who uses this Terraform remote states. I think even GitLab provides something like that. It's not Git repository, but it's some interface, like an API or something like that.
GitLab has a interface for that.
Yeah, and I think that the solution would be actually the same as with the regular code, which means that we would use this remote state plus also the merge requests. So people will not be just randomly committing and executing something, but will be doing merge requests, and just after the merge request is merged, then the Terraform will be executed. Yeah.
Yeah, so I have seen that GitLab has some support for Terraform. Unfortunately, I didn't get to play with that yet, but Terraform is pretty popular. So I guess it would be it could be used for something like that. Anything else? Otherwise,
Go ahead.
yeah. Okay, so we were at what needs to be done. Yeah, so as I said, Terraform is written in Go. And the plugins are also should also be written in Go. I think it might be possible to write them in other languages, but but really all the documentation is written for Go. So it would be it would be desirable to do all this stuff in Go. So we'd need a API wrapper for the openQA API that's written in Go. I guess this shouldn't be too hard to pull off. I've started hacking something together yesterday. I didn't get too far yet. But I mean, I'm also not really a Go expert and also not a openQA expert, but it should be doable. Then we need to actually implement the provider. So sadly, the openQA client is not yet done. So I haven't really looked into how complex that would be. But I hope it wouldn't be too hard since essentially openQA, since essentially Terraform, you just need to teach it how to create, destroy, and update stuff. And that's already and since openQA provides a pretty nice REST API, that could be that shouldn't be too hard. Fingers crossed, all of them. Yeah, and then we need to test it since I mean we are a QE team, so not testing it would be impossible. And with that,
I think Felix has something to add as well.
Yep.
Yeah, I mean we are already at the most important slide. Let's grab the pitchforks, the torches, and get into
Street
get
fight.
into a discussion.
Okay, then I'm the first one who lights up the torch. Then I already started with a Go library for accessing the openQA API. I give you the link. Perhaps
cool.
you find it useful in this point. It's still very experimental, mostly for the needs that I needed in openQAmon, but perhaps that helps you to kickstart the project already a bit.
Yeah, I think it's a nice idea. We should use your work, Felix, to as a base for this.
That sounds great. I'll take a look. So not having to write everything from scratch is certainly a good idea.
All right. What we can also consider are alternatives. So what are the different ways of how currently settings managed, and how could existing approaches be extended maybe? Where do they have their benefits, advantages, disadvantages? So of course there is one way, which is to say, well, you use the web UI of openQA, just manage the settings there, right? Another way is to say, well, we just and this is actually already in place, that openQA settings, for example, for openQA SUSE QE, and I think there's also a prototype for openQA OpenSUSE.org, how would be possible to store more in Git repository and apply from there. The approach taken there is still, well, for job templates, it's basically complete YAML document. Save them, but of course we need to have some kind of mapping structure on the next level. What's done there is that you have some kind of, well, again, YAML and JSON file, and then maybe it's at that point it's a custom parser to say walk over all the files, read out from there the mapping, and send the according API calls. So you have some kind of scripting which does that. And then, for example, Fedora QA, they also have all their settings in a Git repository. So what's done there is that openQA has this built-in template. So you have load templates and dump templates, which also includes all the test settings and all the machines. This had been there for ages. I think the big disadvantage of that approach is that it's not easily the raw format of the files is not easily readable and so not that easily digestible from the out. And what these approaches are lacking is any kind of testing. I think this is something which Terraform could provide, that you have this. I don't know how much would it be able to offer something like show me what we would change without applying.
This is Terraform
Yeah.
plan basically.
Yeah, exactly. That's Terraform plan. It will show you I'm going to do now this. You
Yeah.
want me to do that.
And I'm wondering how much does any kind of wrapper, like API wrapper, need to know so that it can get that, because somehow we would need to see like, okay, what we currently have and what you like to change, and then I can tell you what the diff would be, right?
I'm not exactly sure what you mean by that.
Well, let's assume you have an empty OpenKey instance and you have one where you already previously applied an older state. The base state differs, right? But what's your Terraform definition promises you is that, well, regardless of that, in the end, we will end up with the same, right?
Yeah.
So I guess
That's right.
yeah. So I guess the Terraform plan would tell you something different. It would tell you for the empty instance, like, well, it would roll out this 10,000 resources, and in the other case, it would say like, I only need to add this one test suite.
Well, actually, for it would tell you the same thing for both instances.
Oh, okay.
If you never ran Terraform on any of those.
And I see. So it saves like the local state then.
Yes. So this is so Terraform, what it is, it has these TF state files where it stores the state that it applied and then that it created.
Right.
So if you connect to an instance and it already has stuff, Terraform will still try to apply everything.
Yeah.
If there's already test suites with the matching name, then stuff will break. But Terraform can also do this Terraform import, which I don't know how it exactly works.
Yeah, so you would be able to get some data.
Yeah.
I see. Okay, cool. Pavel.
Yeah, I don't know if it was already said here or not, but in many projects we already have job groups defined in YAMLs in Git, and usually there is a CI because the openQA has some API for testing the YAML of the job group, right? So the YAML is tested before the PR is merged, and when the PR is merged, the YAML of that particular job group is just applied. And usually on top of every job group, which is managed like that, we have some comments saying that do not modify this job group manually as it's modified in Git. Instead, go to this Git repository and create a merge request.
Right.
And I agree that Terraform would be most probably better. It might have more functions. I wish that we don't manage only job groups, but also test suite machines and stuff like that using such. But yeah, we already have at least something. That's what I wanted to mention.
Yeah, correct. That's why what I'm saying. There are already existing solutions.
Yeah.
And of course we need to compare any new approach against that. There's
Yeah.
also one, let's say, one outlook, and what we're discussing here might be the implementation approach of that, which is that we have a so-called saga in the backlog of openQA features that we want to do. The goal is clear, and done. You already started with that. We want to have everything stored in a version control, let's say in Git, right? And that one should be human readable. So it should be that at best we can review these changes and we can test these changes before applying the changes, before making harmful changes. So with that we can see some kind of preview. Would that be sane? We can have some preview of what would actually change. And then we would have some kind of integration in the CI or some kind of pipeline. It could also be the other way around, that we have something in Git and then openQA maybe reads it directly, shows it in the web UI accordingly, and introduce all these changes. So that's the goal. That's clear. This is one potential implementation. Yeah, and
Should
as Jose,
Terraform actually care about that part though? Like, shouldn't the Terraform provider just provide the machines that we need to run tests on?
yeah, that's
Like,
a good
it
that's a
shouldn't
good
need to
point.
know all of the setup that's needed to
No,
test
sorry.
groups and jobs, right?
This is about something else. So Terraform shouldn't, so this Terraform provider shouldn't create the workers for openQA.
Yep.
The Terraform provider should really manage the settings of the openQA instance itself.
So maybe I got confused a bit earlier. So you were showing
Probably.
us the machines and such being created, right? And I thought
Exactly.
that would
Let me.
hypothetically be OpenQA hosts
Could
that then
I
run
please
workers.
stop you? Could
Yeah,
I
thank
stop
you.
you
Sorry.
for just a second? So what I'm trying to exploit is this thing, that Terraform is more generally a thing that tracks state and applies desired state. Stop thinking about Terraform as something for spinning up public cloud VMs. Think of it as a tool that manages state, and that you can use to set a system to a desired state. And what I'm proposing is we define the openQA settings, so essentially test suites, job groups, products, yada yada yada, in a Terraform file, and we tell Terraform, please apply these settings to my openQA instance. Terraform will take a look what has been already applied, what is missing, adjust everything that is there, create new stuff, delete stuff that's no longer in my defined state, and set and adjust and essentially synchronize my configuration file with the openQA database via the openQA API. This is really not about creating workers. It's just what Terraform is being mostly used for, because having some public cloud infrastructure, that's also state, but it's another form of state. Does that make sense?
Yeah. I think I did have the wrong idea of it, or I guess the main use case might be a different one.
So if I may, so essentially you're planning on using Terraform in the form of Salt, because both will just be managing states in the end, right? So you don't want to have all those infrastructure parts, just a pure state engine, which is the same as Salt is offering.
No. Salt doesn't so unless I've misunderstood Salt completely, Salt has no built-in way how to undo stuff that it did.
Yeah, that might be true, yes. Yeah.
Yeah,
that
so
I
that's
think that's a
that's
good
the
point.
thing that I'm really lacking.
The
Since
undoing part is the missing part, yes.
yeah,
Yeah,
so
so that's kind of true because you know, for example,
because
what
it's a
I
hard problem.
yeah, and I think also it has a slightly different use case. So think about where they started
Yes.
from. So Terraform starts from let's spawn clean cloud instances. So you can really say if you want to go back to before you just destroy the machine. And Salt comes more from the this old precious snowflakes where you say let's only control the parts which are explicitly mentioned, meaning it will not touch all the other parts, meaning if you remove certain parts from the salt states, it will not touch them and therefore it will also not clean up and not remove part. Unless you tell salt, for example, you can say this file must not exist, then salt will remove the file. Right. Anton?
Yeah, exactly. You would need to have the
Sorry.
empty state as a state defined to undo stuff.
Which would be likely very messy. Hard to achieve.
Probably, yes.
Yes.
So people, I can see that we have a very disciplined audience. Feel free to just speak up, Anton.
Yeah, so but actually, I don't see how we will exactly use this feature of undo in case of openQA. So let's imagine we have let's simplify everything, and we have a Terraform state file which contain 10 test suites, and then someone add 11th test suite, and we do Terraform apply, so openQA have 11 test suites. And then for some reason it breaks everything, and we decided that we need to roll back this last state. Yeah, of course we can do git revert, but this would be not a Terraform feature then. Then we can use git revert even without Terraform. And in terms of Terraform, what we can do, Terraform destroy, but Terraform destroy will destroy all 11 test suites, and this is definitely not what we want to. So Terraform doesn't provide feature like transactional updates and then roll back to one step back.
Yes, but it was. I still believe it would be a net win, because it would allow. So I'm coming from this currently. So what I've done over the past year is that I've created a test suite for the Kiwi image builder that you might know from the Open Build service. And I've written some tests that are in openQA, and I've also written a script that will set up all the test suite job groups, etc. pp on an openQA instance. Now the problem with that is if I change anything in this in the infrastructure setup, I need to myself destroy the previous state. And if I would have this thing in Terraform, then I could just tell Terraform to apply my new state, and it would clean up after me if I decide that my test suite should no longer be called Kiwi test image, but Kiwi test ISO image, and it would destroy the old one. And the advantage would be we could have multiple independent teams could manage their states. For this rollback stuff, of course, you need Git for that. So that's I think that's pretty clear. You definitely need to have all this stuff in version control. That's so that was I was kind of expecting that we'd keep these things in Git anyway.
Yeah. Okay. So let me try to summarize a bit at the point, and you can correct me where I'm missing something. So basically, we have seen. We have agreed on the challenges. We see challenges which we normally would foresee regardless of the actual implementation. We have received a lot of positive feedback. People like the idea in general. It could be one way to go. There's already a start with a Go library for the openQA API, so I think this is a really good starting base. And yeah, so then would you say this is good enough as a first step, and then let's see how we can continue with that experiment?
Well, I mean, I'd say if there's generally interest in having something like that, I'd try here and there maybe work on a really rough prototype. But I was so my intention with this presentation was mostly to gather feedback if there's if this is something that people would actually want to use, since I must confess I have no desire of creating yet another tool that will just rot on GitHub and no one will take will touch it. And whether people even think that this is a good idea.
Yeah, I guess we are in the undecided state so far. So what you could do is you could create a ticket and see about other feedback that we receive asynchronously and work based on that and make it. And there was also another note in the chat from Yanis mentioning Weeks and NIX are ideas to. With this, I would like to stop here. So Dan, thank you very much for this very interesting topic. We don't
Thanks
have
for having me.
yeah, thank you. We don't have a topic yet defined for the next week. So yeah, we're still open for discussion. It could be done there. I guess we could have some discussion about review practices, such also. And with that, thank you all and goodbye. You're happy to stay here and have some chat. See you then. Until next time.